Hey everyone. In the world of data, we're kind of obsessed with precision, right? We love our numbers, our clean categories, our simple true or false. But the real world isn't like that at all. It's messy, it's full of vague ideas like hot or fast or risky. So in this explainer, we're diving into a really cool tool that helps bridge that gap. It's called fuzzy logic. Let's get right into it. Okay, let's start with a really common problem. Picture this. You're working with a database and you need to find all the young users. How do you actually do that? I mean, do you just pick a number, like, say, under 30, and just make that the rule? It feels a little random, right? Yeah, exactly. That standard SQL query you see there, that's classical logic in a nutshell. It draws a hard, sharp line in the sand. You're either young or you're not, period. But that's just not how we think, is it? For us, young is a sliding scale. Someone who's 29 is definitely young, but someone who's 30, well, they're still pretty young too. So classical logic is like an on-off light switch. But real life, it's much more like a dimmer switch. And that right there, that's the big problem we need to solve with classical logic. If we want to really capture what young means, we have to get away from this black and white true or false world. We need a system that can handle, well, shades of gray. You see, the logic that powers most of our databases is built on something called classical set theory. And it's totally binary. An item is either 100% in a set, that's a value of 1, or it's 100% out of the set, a value of 0. There is absolutely no middle ground. It's all or nothing. But this is where fuzzy logic comes in with a really brilliant idea. It says, hey, let's swap out that on and off switch for a dimmer switch. And that one change completely flips how we look at the problem. We stop asking if someone is young, and we start asking how much they are young. It's a subtle but huge shift. So that brings us to the formal definition of what's called a fuzzy set. Instead of just having two options, 0 or 1, an element can have a degree of membership anywhere on that spectrum. So for example, a 25-year-old could have a membership of, say, 1.0 in the set young. A 35-year-old, maybe they're at 0.5, and a 60-year-old is probably down at 0.0. You see? It's this smooth, gradual change. Okay, so we've got this idea of degrees of membership. That's cool, but how do we actually use it to define those messy, real-world concepts we talked about, like young, tall, or maybe even high risk? Well, we do that with something called a linguistic variable. And this is a really powerful concept. Think about it. Instead of the variable age just holding a number, its values can be actual words, the words we use every day. So age could be young, middle-aged, or old. And each one of those words is then defined by its own fuzzy set. And this naturally leads to the next big idea, which is called granulation. The basic idea is you take the whole range of a variable, like age, from 0 to, say, 100, and you cover it with these overlapping fuzzy sets, which we can call granules. So the young set might slowly fade out, just as the middle-aged set is fading in. This gives us a really smooth, natural way to describe the entire range. All right, so we've got fuzzy sets and these new linguistic variables. The next obvious question is, what about logic itself? How do things like and, or, and not work when we're not dealing with simple true or false anymore? This is actually the really elegant part. They're extended in a super intuitive way. If you want to find the degree of something being young and tall, you just take the minimum of the 2 degrees. If you want young or tall, you take the maximum. And for not young, you just subtract its degree from 1. It's really simple, but it's incredibly powerful. It lets us build all sorts of complex rules using these simple human-like terms. Being able to model human language like this is amazing, for sure. But this brings up probably the most important question for anyone who works with data. This is all great, but do I have to define all this stuff by hand? And the answer, thankfully, is no. The real magic happens when we can learn these models directly from our data. Oh, absolutely. And this is really where fuzzy logic becomes a total game changer for data analysis. Its true power is that we can automatically pull these easy-to-understand, human-like models straight out of the data we're already working with. So let's just walk through how that works from a high level. First, the system granulates the variables. That means it defines all those fuzzy sets we talked about. Next, it generates rules. It looks at every single data point and figures out what kind of if-then rule it supports. Like if age is young and income is high, then credit risk is low.
Then it assigns a weight to every rule based on how strong the evidence is in the data. And finally, to give you a single, clear answer, like a specific risk score, it has to determine the output. This last step is called defuzzification, and it's basically where it combines all those rules to give you one final, actionable number.
Okay, so let's pull all of this together. Why should you care about this fuzzy stuff? What's the real advantage for someone who works with data day in and day out? Well, I think the biggest takeaway here is that fuzzy logic gives us a solid mathematical framework for dealing with all the vagueness and ambiguity of the real world. It lets us build models using words that actually make sense to us, like high risk or low temperature. This makes the models so much easier to understand compared to a lot of those black box machine learning methods. So it's not just about getting an answer, it's about understanding why you got that answer. It's really the perfect bridge between raw numerical data and our own human knowledge. So the next time you run into a concept that just doesn't fit neatly into a true or false box, remember that dimmer switch. Maybe give fuzzy logic a thought. And that really brings us to our final question for you to think about. How could adding a little fuzziness change the way you look at your own data? We'd love to hear your ideas down in the comments. And hey, if you found this helpful, do us a favor and like, share, and subscribe for more explainers like this. Thanks so much for watching.